Welcome to Module 4, Lesson 1, Applying GCF and LCM to Fraction Operations. So after today's lesson, we are going to be able to use the GCF of two or more fractions to simplify them. So really here what you want to remember is the GCF helps us simplify. So remember, factors are what can divide numbers without getting remainders. So it makes sense that they are going to help us simplify or make our fractions smaller. And the LCM is going to help us make them like fractions. So the least common multiple here, you can think of the fact that it's common, and so it's going to make them like. And for them to be like fractions, they have to have the same denominator. All right, so as a review, when you're multiplying fractions, it's really, honestly, it's the easiest thing that you're going to do with fractions. I love multiplying fractions. It's nice and simple. I just take my numerator and multiply it by my numerator, and then I take my denominator and multiply it by my denominator, and boom, you have an answer. Now, that answer, though, sometimes is not always in simplest form, so we have to put it in simplest form. And I'm going to give you an example here. So if I took 2/3 and multiplied it by 3/4, again, I do my, denominator times denominator, and I do my numerator times numerator. On top, I get 6, and on bottom, I get 12. Now, to be in simplest form, we need it to not be able to divide any further. So these two numbers need to not have any common factors. Well, in this case, they have a couple of common factors. And so what students like to do, and I was totally included in this, I knew that they were both divisible by 2, so I got 3/6. Well, wait a minute, now I can do it again because both of them are divisible by 3, and I got 1/2. Now, yes, I did get to 1/2, and 1/2 is the correct answer. But I want to take all of this, and I want to make it one step. So to do that, I figure out what's the GCF. That's a C, not a G. There we go. Of 6 and 12. Well, I know the GCF of 6 and 12 is 6, and we'll continue to practice that. But if that's the case, that means I can take both of these and divide them by 6. In doing that, I get 1/2. So I just took all of this that I did up here and simplified it into one step. That's what we're going to be practicing here. So I'm going to give you two examples here. We're going to use two different forms of simplification. One, using that GCF, but doing it with the product. So in this case, I have 1 times 3 gives me 3, and 3 times 5 gives me 15. Well, I can list the factors of 3, and I know they're 1 and 3, and I start with the largest. Can 3 divide 15? So is 3 a factor of 15? Yes, it is, so that's the GCF. So then I take that GCF and multiply the numerator and denominator by it, and I get 1/5. Now, the other way I can do it is I can use cross simplification. And I really do want you guys practicing with this because it makes your life a lot easier. Trust me. It's a little confusing to start out with, but once you get the hang of it, it becomes super simple. So cross simplification means that we're looking at our diagonals. So I'm looking at 6 and 3, and I'm looking at 2 and 7. All right? So what I'm looking for is, do they have a common factor? So 6 and 3, do they have a common factor? Yes, and that common factor, the largest common factor, or the GCF, is 3. So if I divide 3 by 3, I get 1. And if I divide 6 by 3, I get 2. Do 7 and 2 have a common factor? No, so 6 and 3, the GCF was 3. And so that's what I divided them both by. 7 and 2, the GCF is 1, so I can't divide them. So what some students like to do is they like to rewrite the problem. Now instead of 6/7, it's 2/7 times 2 over 1. And now when I do that, I get 4/7. And my answer is already in simplest form. Now if I want to double check that, I can go ahead and multiply as I regularly would have. So doing 6 over 7 times 2 over 3, I would have gotten 12 over 21, both of which are divisible by 3, which we saw here, which would have given me 4/7. So notice I got the same answer, but here I simplified first and then multiplied. You really want to, I would practice it with my small numbers, but it's really nice to use when I have larger numbers in my fractions. So, for example, we're going to actually do number 5 first. So if I look at 7 and 21, so 7 and 21 have a GCF of 7. So I can take 7 and 21. 21 divided by 7 is 3. 7 divided by 7 is 1. So now instead of doing 10 times 21, I could be doing 10 times 3. However, 10 and 8 also have a GCF, and that GCF is 2. They're both actually divisible by 2. So 8 divided by 2 is 4. 10 divided by 2 is 5. Now my problem has become 1/5 times 4/3, which gives me 4/15. Had I not done that, I would have done 7 over 10 times 8 over 21, and I would have gotten 56 over 210, which isn't horrible, but the GCF of 56 and 210 is 14. That's kind of a tough number to find if you don't really know your multiples very well. Okay, so this is why when you have larger numbers, I really suggest using the cross multiplication. What I'd like you to do is I'd like you to try the other 5 problems and then come back and check your answer. So here you should have found that you got 3/30. Both of them were divisible by 3 because that was GCF, and you should have gotten 1/10. Here you got 21 over 36. The GCF was, again, 3, and you got 7/12. Here you got 6 over 21. Again, that GCF was 3. Apparently this book loves it some 3s. 6 divided by 3 is 2. 21 divided by 3 is 7. Here you get 8 over 35. Now the GCF here, if you weren't sure, going through and checking to find that GCF, you can list the factors of 8. 1, 2, 4, 8. You can say, well, is 35 divisible by 8? No, so 8's not the GCF. Is 35 divisible by 4? No, so 4 is not the GCF. Is it divisible by 2? No, so 2 is not the GCF. So it has to be 1. Well, if the GCF is 1, it's already in simplest form. Here you got 6 times 1 is 6, and 7 times 6 is 42. Well, look at this. You multiplied by 6 on both the top and the bottom, which tells you both of these have to be divisible by 6. If you multiplied by 6 to get your answer, then you should be able to divide both your answers by 6. So you would have gotten, 1 over 7. And let's put 7 on top. All right, so now we have a class of 18 students. And the teacher asks how many students in the class have pets and finds that 5/9 of the students have pets. How many students have pets? Well, of tells us to multiply. Okay? Step 1 tells us how we can check our answer. So if you are following along closely with this, we can look and notice that we have 18, and we're not going to change that, but we're going to estimate 5/9. Is it closest to 0, half, or 1? Those are our benchmark numbers. Well, half of 9 will be 4.5, so it's closest, and 5 would be closest to 4.5, so it's closest to half. So I can take 18 and multiply it by half, and I get 9. So I know my answer should be close to 9. It's not going to be exactly 9, but it should be close to 9. So if I all of a sudden get like 36, my answer is incorrect. Okay, well, I'm doing 5/9 of 18. So in this case, when I'm doing that, in order to multiply with whole numbers, I have to remember I have to make them an improper fraction. To make them improper fractions, I have to put 18 over 1. Because that means I have 18 pieces, and if I put 1 in each group, it would give me 18 groups. So these two things are equivalent. Now I can do this one of two ways. I can either do my cross simplification, or I can multiply straight across. I would like to try cross simplification because 18 is a pretty big number to multiply by. Both 18 and 9 can be divided by 9. Here I would get 1, and here I would get 2. Now all of a sudden I'm doing 5 over 1 times 2 over 1, which is going to give me 10 over 1, which I know is equal to 10. So that tells me that 10 students have pets. All right, so analyzing the relationships. So here we're taking a look at, is the product of a fraction that is less than 1 and a whole number greater than, so is the product of a fraction that is less than 1 and a whole number greater than or less than the whole number? Okay, so looking at all your answers, so thinking about a whole number times a fraction, and that fraction has to be less than 1. Well, when you're taking that whole number and multiplying it by a fraction, you're cutting it up into pieces, and you're finding just a little piece of that pie. So in this case, your answer is always going to be less than. Okay, so let's take that and put it into words, and I'm going to type to spare you the time of me writing it. So less than, because a fraction of a whole, if the fraction is less than 1, is always less than the whole. Okay, and it's happening because you are breaking the whole into smaller pieces and only taking some of them. Okay, so again, you're breaking this whole into smaller pieces. So let's say you were doing 2 times half. Okay, well, 2 times half is going to give me 1, because that's telling me that I'm taking 2 pieces and I'm only taking half from each. So this half and this half, which are going to give me 1. So notice my answer got smaller because I'm only taking small slivers of each. Okay, so we're going to go through. We're going to practice these. Again, all of them. So go through, practice. All of them go over 1. If you can remember that, life is grand. And then we're going to take a look at 13 together. So I actually want you to try them on your own and then come back and check your work. I'm going to continue to practice cross simplification with you because it's a harder problem. So 8 and 24 are both divisible by 8. I get 1 and 3. So here I get 15 over 1, which is equal to 15. Okay, and then here I can't have any, or there is no cross simplification. So 1 times 8 is 8. 3 times 1 is 3. So I can't leave it like this. So 3 goes into, so how many groups of 3 can you make with 8 pieces? Well, 2. I would use 6 pieces and have 2 left over out of the 3. Well, and we'll look at 12 and 13 together. I apologize, I didn't catch that other one was improper as well. Here, 20 and 5 are both divisible by 5, so I got 1 and 4. And then I get 12 over 1, so my answer is 12. 14 and 4 are both divisible by 2, so I get 7 and 2. So this is 7 times 1 is 7 over 2. 2 goes into 7 3 times with 1 left over, so my answer would be 3 1/2. Now with fractions, remember what fractions means. We talked about this. This means 3 groups of 10 plus 7 left over. So 3 groups of 10 means I multiply, and then I add that extra 7. So I have 30 pieces plus the extra 7, so I have 37 over 10 times 7 over 1. Okay, so now,
say we've had some students going to the boys' bathroom this morning and splash water and soap around. Staff, if you can
so I apologize. I know you can hear Kurt in the background. At this point, you can ignore him. So here I'm going to go ahead and I have to multiply because I have no cross simplification. So 37 times 7. 7 times 7 is 49, carry the 4. 3 times 7 is 21, plus 4 is 25. So I have 259 over 10. So now I have to figure out how many times does 10 go into 259. So I'm actually using long division. Well, 10 goes into 25 twice. Minus 10, I have 5, bring down to 9. 10 goes into 59 5 times, minus 50. I have 9 left over, so that remainder of 9 becomes my numerator. So yes, this is 259 over 10. However, my answer should be I have 25 groups of 9 tenths, because I have that remainder of 9 out of 10. So then again, for 13, I have 2 groups of 10, which is 20, plus the extra 3, so 23 over 10 times 10 over 1. I can cross simplify, yay! Both of these can be divided by 10, so I get 1. So I get 23 over 1, 23 over 1, so my answer is 23. All right, last but not least, the LCM and creating like fractions. Okay, so when we want to write fractions in simplest form, we want to do our best to keep our fractions as small as we can. Okay, so in this case, what students usually like to do is they usually like to just multiply 15 and 6. So 15 times 6, and use 90 as our new denominator. Well, instead, we're going to use the LCM. So I have 15 and 6. Both of them are divisible by 3. Here I get 5 and 2. Both are divisible by 1. So if I do 3 times 5 times 2, I can ignore the 1, I get, well, this is 15 times 2 is 30. So the LCM of 15 and 6 is 30. So instead of using this big 90, I'm going to use 30 instead. So what that means that I can do is I can take 8/15 and 1/6, and I can figure out what to multiply them by to get to 30 instead of getting to 90. So 1/6 times something, and that gave me 30. So in this case, I know 15 times 2 gives me 30, and what I do to the bottom, I have to do to the top. So I get 16/30. I know 16 times 5 gives me 30. So what I do to the bottom, I have to do to the top. So now I have 16/30 plus 5/30. So 16/30 plus 5/30. This is going to make it a lot easier for me to simplify my answer because I'm not going to have such a large answer as I would have had with 90, because these numbers would have been a lot bigger. So when I add this, I get 21/30, because remember, we don't add our denominators, we just add our numerators. I know that with 21/30ths, both of them are divisible by 3, and that is the GCF. And so my answer is 7/10. Okay, so again, you can use the LCM to create smaller fractions and then use the GCF to simplify them. Now, there is no cross simplification with addition. That only works with multiplication. Okay, so then here I want you to take a look at the reflect question, and I want you to answer this for class, well, tomorrow, you know what I mean, for the next class, okay? So you're doing this one on your own. So think of, could you use the LCM to solve this, even though it's subtraction, and see what happens. And remember, when you add and subtract fractions, you have to have common denominators. Okay, so here I have 5/14 and 1/6. So the LCM here, so 14 and 6, both are divisible by 2. I get 7 and 3, both are divisible by 1. So 2 times 7 times 3. Well, I'm going to do this one first. This is 21 times 2 because that's easier, so 42. So what times 42? What times 14 gives me 42? Well, I know that it's 3 because 4 times 3 is 12. Carry the 1, so I have to multiply by 3 up here, and I get 15. So then I have to do the same thing with 1/6. And I know that I multiply by 7, so I have to do that on top. So I get 7 42nds. So I do 15 42nds plus 7 42nds, which gives me 7 and 5 is 12, so 22 over 42, both of which can be divided by 2. So I get 11, maybe, there we go, 11 over 21. Okay, now there is a ton of work that goes with these. So instead of taking all this time to go over it on the video, I am just going to give you the answers, okay? And then if you do have a question on it, if you didn't get the correct answer, please make sure that you ask me about it in class. Otherwise, this is going to be a video that is going to end up being like an hour long. I don't want to do that to you. So here you should get 1/24. Number 19, you should get 6 and 13/15. Sorry, I wrote that one a little crooked. Here you should get 4/15. Number 18, you should get 1 and 11/20. And the last one, you should get 3 and 1/42. Okay, again, if you have any questions or if you didn't get them correct, please, please, please circle, highlight, whatever you need to do, and we can talk about it in class. Okay, and now you have your guided practice problems. Please remember to fill out your answers on the Google form. Take your time, okay? Take your time, and I am going to ask you to show all of your work. I gave you space to show your work, I believe above this. Make sure you show that work and find that LCM, all right? I'd like you to do a couple of these with cross simplification, all right? As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.